What we're doing today is flowchart thinking. We've done flowcharts before. We did them with our proofs when we talk about proofs, and it's just a way to outline a given proof. And the flowchart's already been set up for you. The homework assignment will be a paper copy. You're going to have to actually turn that in. It won't be on Big Ideas Math. It will be a paper assignment. And the flowchart for that has already been set up. We just need to fill it in. And what we're going to be doing is using this flowchart thinking and CPCTC. Okay, now before we move on, let's see here. CPCTC. So what does this stand for? Corresponding parts of congruent triangles, what? Are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. CPCTC. So we're going to be using flowchart proofs and CPCTC together. And that's all we're going to be doing today. So when we look at this here, we're going to be using this flowchart proof in CPCTC and some of our triangle congruency statements, our triangle congruency theorems, to prove that angle A and angle E are congruent. Well, I know the last one should be what? Angle A is congruent to angle E. Yes, because that's the last thing we're trying to prove. We're trying to prove that those two angles are congruent. So let's see what we know so far. Well, they told us what? Well, EC is congruent to AC. Line EC and AC are congruent because they told us it, yes? How do we know that they're congruent? It's by given. ER and AR would be congruent because it was given. And lastly, is there anything else congruent? RC would be congruent to what? RC is congruent to CR, or we can just say RC. Same line. It's congruent to itself. So that's pretty much everything that would be congruent in these two triangles, yes? Do I have enough information to use one of my congruency theorems? Well, I do, don't I? What do we have? We have a set of sides, a set of sides, and a set of sides. So I can say that triangle what? So RAC would be congruent to triangle what? So RAC, REC, yes. By what? Side, 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 and we can really put in congruency theorem. But side, side, side would be enough for me. So since the two triangles are congruent, we can say that angle A and E are congruent. By what? CPCTC, because corresponding parts of congruent triangles are congruent. And that's it. That's all we have to do with this here. Questions on this here? Any questions on any of this so far? We ready for the next one? Okay. So let's see here. So they gave us that SE and SU are congruent, yes? They also told us that angle E and angle U are congruent, yes? So what do we have so far if we were doing angles inside? We'll have an angle, a side, and then, well, angle or side. We don't know what the third piece is, correct? In the other triangle, we do have an angle and a side. So we have two angles that match up, an angle in each one that matches up, and a set of sides that match up, yes? So if I look at all of the ones that I have, angle, side, angle is one of them, yes? I mean, out of all of them, because we had side, 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 angle, side, angle, side, and angle, angle, side, yes? Could we have that MS and OS are congruent to be able to show that the two triangles are congruent? So what would that give us? That would give us what? Angle, side, side. Was that one of the ways that worked every single time? No. It would work if it was a right triangle and we had hypotenuse leg, but we don't have that. So really, what are we looking for? We have an angle side. We need an angle. Most likely, that's what we're going to be using. Yes. So one of the angle sets that we know is that angle E is congruent to angle U. Yes. How do we know that? That is given. I have a set of sides. SE is congruent to SU, and that is given. So those two pieces of information so far. So now we need a what? Another set of angles. Because angle side side is not one that works, because it's not one of the ones that works every single time. So we need another set of angles. Is there a set of angles that we know that's congruent in this figure? 1 and 2. Angle 1 would be congruent to angle 2. Why would they be congruent? It's dealing with opposite, but we call them what? Vertical angles. Because they are opposite each other, where those lines cross. Because when we have two lines cross, the angles that are opposite them are going to be congruent because they are vertical angles. Vertical angles will always be congruent. So that's how we can say 1 and 2. These two angles here are congruent because they are vertical angles. So now do I have enough information to say that the two triangles are congruent? Yes. Because we have an angle, a side, and an angle. So we can say by angle, side, angle that triangle what? MES or US. Because as long as we have a statement that corresponds for these two triangles here, we're good. So we can use them in any three ways. Now what we were wanting to say was what? MS is congruent to, and we can say that because of CPCTC, because those two parts, those two lines are corresponding to each other inside these two triangles, or part of these two triangles, and the corresponding parts of congruent triangles are congruent. And that's all we have to do for this here. Okay. We can go in and fill in the first two pieces of information because they're what's given. I is the midpoint of CM. I is also the midpoint of BL. And this here is given by given. I is the midpoint of BL. So it's our two given pieces of information we're filling in. If you don't have enough room in those boxes, that's fine, because, again, you can write outside of it like I did. So we're using just the two pieces of given information. Yeah, so we can say that those two angles are congruent, because 1 and 2 are, again, vertical angles for this here. Now, I'm going to put this down here. Angle 1 is congruent to angle 2 by vertical angles, or our vertical angles theorem. So we can say that these two angles are congruent. Now we have those other two given pieces of information, yes? If I is the midpoint, it means it's in the what? Middle, yes? If it's the midpoint, it's the middle. So since it's in the middle, it's telling me what? So CM, that CI and MI are going to be what? Congruent, because a midpoint cuts a segment into two congruent segments, yes, two congruent parts. So because of midpoint, I can say that CI is congruent to IM. Well, why do we know that? The definition of midpoint. The definition of midpoint tells me that it cuts it into two congruent segments. It cuts it in half. The midpoint is the middle. It cuts the line in half, yes? If that's the case, if I is the midpoint of LB, or BL, it's going to cut it in half as well, so that we could say that LI is congruent to BI by definition of midpoint. And I'm going to have to abbreviate that, otherwise it's going to run into the next box. Any questions on any of this so far? So a lot of what we're doing here is just using definitions, isn't it? Just using what we know about midpoints, vertical angles, to get what we need. Because looking at this here, I have a set of sides here, a set of sides here, and an angle in the middle, yes? Is this one of our congruency shortcuts? Yes. Side angle side is one of them? So I can say that triangle, what? CIL is going to be congruent to what? Triangle MIB by side angle side. First time a little bit of SAS proved anything. So now that we have the two triangles are congruent, we can say any of their parts are congruent as well. Yes? So we wanted to show that CL and MB are congruent. Well, yes, I can say that CL is congruent to MB by what? CPCTC. Because once I prove that the triangles are congruent, their corresponding parts have to be congruent as well. Mm-hmm. Or is it MB? MB. Yeah, because what we wanted to prove was CL and MB were congruent. And that's it. Questions on this here? Any questions on any of this here so far? I think we have 2 left.
I think so, yeah.
3 left. Oh, boy. Okay. So there's some information here, a little bit I'll help you with. So let's look at what, so they want us to show that angle W and angle E are congruent. Given any W is isosceles, with Wn is equal to En, and Ns is the median. Well, triangle NEW is isosceles. Well, we know that because it's given. So we have that. Now, yeah, because it's isosceles, oh, got to put the eraser down. Wn is going to be congruent to En by, well, that's really still given. It's also part of isosceles triangle. That works out. Now, what do we know about isosceles triangles? The angles opposite the congruent sides are what? Congruent, yes? What was that? That was our isosceles triangle conjecture. Because the isosceles triangle conjecture told us that if it's an isosceles triangle, the angles opposite the congruent sides are congruent, yes? That's what we're wanting to prove, so we can't just come out and say that yet. So we have this here. Now it also says that NS is a median, yes? Well, really from this statement here, we're going to end up saying that WS is congruent to SE. Now this is by definition of medians. This is true. We haven't gotten into what a median is and how it works and how it operates, but we will get into that in chapter 6. So hopefully you're not tired of triangles yet, because this whole chapter has been about what? Triangles. Chapter 6 is still triangles. And when we get into chapter 6, we're actually going to talk about medians and what they are and how they work, as well as centroids, orthocenters, incenters. Yes. Triangles are the most fascinating out of all of them, because they have so many properties to them. Trigonometry is, y'all have heard of trigonometry? Yeah. It is all based off the study of triangles. And it extrapolates a little bit from that, and we can actually apply it to other things in other situations, but it really started with triangles. And it actually works out triangles show up everywhere. Now, so we have a set of sides that are congruent. We have another set of sides that are congruent. Do we have anything else that's congruent? NS. Well, that would be congruent to itself. And if we were being, because we can say same line and that's what we're going to put, but if we wanted to be a little bit more meticulous, we would talk about kind of it being congruent to itself, the reflexive property of congruency. But for now, we can just say same line. And since we have that, we can say that what? Triangle WNS is going to be congruent to triangle ENS by our side congruency theorem. So triangle WNS is congruent to triangle ENS by our side. So therefore, we can say that angle W, which is what we wanted, is congruent to angle E by CPCTC. And that's it. Questions on this here? We ready for the next one? Okay. Now we're going the other way. We're going the other way around. Because on the last one, we wanted to show that since it's an isosceles triangle, the angles opposite the congruent sides are congruent. Now we're going to go the other way. We're wanting to say that if I have a triangle with two congruent angles, the sides opposite them would be congruent. And if they are, it means it's an isosceles triangle, because an isosceles triangle has two sets of congruent sides, or two congruent sides. NEW, triangle NEW with angles W and E are congruent. So they told us those are congruent, yes? Because what are we looking for? We're looking for sets of angles or sides that are congruent, so we can say the two triangles are congruent, yes? Does it tell us two angles are already congruent? Yes? I wouldn't put it in this one here. I'd put it over here. Angle W is congruent to angle E. Given. Because that first box leading something else, we're looking at information that's giving us more information. Now the other part it says is that NS is in, it helps if I can spell angle right. Angle, bless you, bisector, and this is given. NS is an angle bisector. So what does it mean if something's an angle bisector? It cuts it in half. It's cutting an angle in half. Bisect means to cut in half. So it's bisector. So that means for us, well, in most cases, we'd have to rewrite it as angle in 3 letters is congruent to an angle in 3 letters. Yes? Well, we don't have to do that here. Why is that? How did they nicely give us up in those two angles? 1 and 2. They already numbered them. So I can just say angle 1 is congruent to angle, well, not given. What am I thinking? It's the definition of angle bisector. Because the definition of an angle bisector means that it cuts the angle in half. It cuts it into 2 congruent angles. So let's see what we have so far. I have an angle. I have an angle. We're going to need a side. Because if I had 3 sets of angles, would that work? No. Angle, angle, angle doesn't work. So I need a set of, is there a set of sides that are congruent for these two triangles? SN and SN. SN is congruent to SN. It's our same line. Do I have enough information to say that the two triangles are congruent? Yes, sir.
You also say that WS and S are congruent with the line of an angle bisector.
Not necessarily. Median it is, because you'll end up seeing this here, not next week, but after fall break, or not fall break, Thanksgiving break. A median is a line that connects the midpoint to the angle opposite the line. So that's why we could use it for median, because the definition of a median says it's the midpoint to the angle. Now, here for angle bisector, it's really talking about just cutting that angle in half. So it's not always going to meet at the median or at the midpoint of the other line. It could. There's a good chance it can, and it will for this one here. But at this point, we don't have enough information to say that. Because depending on what the angle is, it might not hit there. if that makes sense. We just can't assume it. Let's see here. Okay. So now we can say what? Triangle WNS ENS by our angle, side, or side, angle. Either one works. So since that's true, we can say that any corresponding parts are true. Yes? So if it's supposed to be an isosceles triangle, I need what? Two sides that are congruent in the triangle, yes? So what sides can we say that are congruent? NW is congruent to NE. By what? CPCTC. Awesome. Did we prove what we wanted to? We did, yes, because two sets of congruent sides. Triangle. EW is EL isosceles. By, well, definition of just because those two sides were congruent, it does show that it is an isosceles triangle. But in a rigorous proof, I mean, we're not doing any rigorous proofs, even these here, they would really want us to state everything out. Any questions on this here? Any questions on any of this here so far? Okay. We do have this last one here, and I'm just going to go on and fill it in for y'all so you don't have to and talk y'all through this. This is given. SE is parallel to NA. Given. And really because SA and NE are parallel, and then these other two sides are parallel. Since SA and NE are parallel, it means angle 4 is congruent to angle 3 by alternate interior angles, because it works out that way, because the whole angle is included for those. Now, we couldn't say anything about 1 and 2 from EA, this first statement. That's why we needed the other one to say that angle 1 is congruent to angle 2 by, again, alternate interior angles. Because the other set of alternate interior angles with SN and NE include a little bit of the angle outside that figure. That's why I can't use for 1 and 3, or 1 and 2. And we have that SN is congruent to SN. It's the same line. So I can say triangle SEN is congruent to triangle. So so I went 1, E, 3. So 1 and 2, I need NAS by angle, side, angle. So we can say that SA is congruent to NE by CPCTC.